So the next thing we're going to talk about is the method of substitution. And the method of substitution just comes straight from the chain rule. So you know that the derivative of a composite function, where you have an outside function and an inside function. In this case, the outside function is f, the inside function is g, right? And so you take the derivative of the outside function, leave the inside function as it is, and multiply by the derivative of the inside function. Okay? So here's the trick that we're going to use that to solve integrals. All right? So essentially we're reversing the chain rule. All right, so what we do to make a substitution is we let the inside function be w. Now, some of you may have learned something called u substitution. This is the same thing. So I think a lot of people learn u substitution because you're using the letter u as the inside function. Your book uses w for some reason. I don't know why, but I learned it as u substitution. But we're going to use w just to be consistent with your book. And so we're going to let w be the inside function, and then when we differentiate, we have dw is equal to the derivative of w dx. Okay, and then we can make a substitution. This will make more sense once we go through an example. You'll probably remember how to do this. All right, so in this first example 4, gonna look at it. Okay, we decide. Okay, where's the inside function? Where's the what's the outside function? Now I'm guessing it looks like this x to the 4th plus 5 is a logical choice for the inside function. So I'm gonna let w equal x to the 4th plus 5. Okay, now I just want to differentiate both sides. So I'm going to end up with dw is equal to 4x cubed dx. Okay, so I just differentiate both sides. You can also think of it as I'm doing dw dx is equal to that, and then I'm just multiplying both sides by dx. Right? You could kind of think of it that way. So then this would go away. And I have dw is equal to 4x cubed dx. Okay? Now what I have over here in the integral is not 4x cubed dx. I have x cubed dx. I would probably like to put these two things together and make a substitution. So what I'm going to do is I'm going to divide both sides by 4. So I get 1/4 dw is equal to x cubed dx, and then you can see wherever I have x cubed dx, I can replace it with the 1/4 dw. Okay, and then down here, this is my w. So what I end up with is the integral of 1 over the square root of w times 1/4 dw. Okay, now I know how to integrate 1 over the square root of w, right? I'm just going to take this. Take this 1/4 and bring it out front. And then this becomes essentially w to the minus 1/2 dw. Okay. And then the integral of that, so I'm going to 1/4 w, so I'm going to add 1 to the 1/2 divided by 1/2, which just becomes times 2. And then, of course, plus c. Okay, so we end up with, I can combine the 1/4 and the 2, and what I end up with is 1/2, and then I have w to the 1/2, but now I can go back to my original definition of w and put the value, write it in terms of x again. So I'm going to have x to the 4th plus 5 to the 1/2. Plus c. Okay, so that's my final answer. 1/2 x to the 4th plus 5 to the 1/2 plus c. I could also write it as 1/2, square root of x to the 4th plus 5. That's a 5 plus c. All right. So I'll meet you for the next example. You can go ahead and actually try the next example, and I'll go through it in the next video.